Alright, for those of you who are having problems with your car overheating, this is for you. We got a fan that's not coming on. And this works for a lot of other cars too. This is the same principle. This is a 97 Honda Civic 1.6 liter. And I'm going to show you the process of elimination of how to diagnose why your fan isn't coming on. And how to isolate each area, each thing that's involved with the fan. Alright, let's diagnose it. I'm going to show you how to figure it out. And let's go. And what I got here is a connector. This is specifically for Hondas. This is an engine coolant temperature sensor connector. I pulled this off a car at the junkyard so I don't have to probe it with the pins. Alright, so what you do is take this off and just slap this on like that. Then I can put my meter on it and check for resistance. Alright, depending on the temperature. Or what the other option is you can hook up these here. On the end of these probes I got, I can change them from the alligator clips to these long probes like that. Or I can put shorter ones on there. I got shorter ones too. But I have different hookups that I can hook up to these leads. But for now, I'm going to use the alligator clips because I'm going to clamp them on to this deal. Alright? So, let's put this on the resistance. Like that. This has auto range on it. Okay, first thing you want to do is check for a 5-volt reference signal coming from this connector that goes into the engine coolant temperature sensor. This 5-volt reference signal is coming from the PCM, and let's put the terminals on there right now and check it. There we go, we got 5 volts right there. Well, 4.9, same thing. So we got 5-volt reference right there. So we know this wire is good here. Wiggle it around a little bit, make sure there's no shorts or open circuits. Check for a break in this line. Okay, so now we know we got 5-volt reference going into the coolant temperature sensor from the PCM. This is all good. This circuit's good here. What this does is it makes it easier for me to get a reading. Instead of sticking these probes in there like that and trying to hold it, I'll just put the connector on like that. Then I change these leads from the probes to the alligator clips, just like this. Set the meter to resistance and just hook them up. Put this one on here. Watch the resistance. Put this one on here. Okay, remember the engine's cold. Okay, so we got 2,340 ohms of resistance. So what you do is you jot that down. Alright? So you put, while the engine's cold, 2,340 ohms of resistance. Okay, now we got this hooked up. What we're going to do is we're going to start the engine and warm it up. We know the engine's cold and we know our reading is 2,000, say 2,300 ohms of resistance. Alright? Based on the engine being cold. Now, we'll go back here to this switch. We're going to test this at the same time while the engine's cold. Okay? This is the coolant fan switch. This is pretty much an off and on switch. So I'm going to take that off like that, set this to ohms. Put this connector back on this one. Alright, hook up the leads to the ohm meter and check if we got continuity. This normally doesn't have continuity right now. Only when the engine is to a certain temperature, like 199 degrees, 207. Only when the temperature reaches that will this switch come on. So right now we're hooked up and we have no continuity. So right now this sensor is open. Okay? So let's go to the next step, warm the engine up. Okay, before I warm the engine up, we're going to check the fan relay and we're going to check the fan. What you do is pull it off from here. pull it out like that. Take this off here. This is to the fan motor right here. Pull that off. Got 2 terminals in there. Alright, hook up one on this side. Just like that. Then hook up, then touch the fan, then touch the other one like that. You hear that? That lets you know the fan's working. Now let me show you from this side. Okay, I got this alligator clip on the positive, this on the negative. Hook up one there, on that side. Just touch it on that side. You don't even gotta clamp it. Watch the fan. So you know your fan works. Okay? But there's an easier way than that. Okay, next what you want to do is you want to check your fan relay. You look on this here, look on the cover of the fuse box in the engine compartment, and look for your fan relay. Cooling fan relay right here. So 1, 2, 3. So it's not this one, because that's bigger than the 20 amp. So your 20 amp starts there. 1, 2, 3. So 1, 2, 3. 1, 2, 3. This is the fan relay right here. What you can do is you could swap them. These are both exactly the same. They do the exact same thing. They both work off of 12 volts. And you can put this one in there in order to see if this circuit's working, operating correctly, to see if the fan comes on. But we're just going to test it like this, right? Okay, now next, what you do is you got the relay out, right? These 2 terminals right here. What you do is you provide 12 volts directly from the battery. We got these 2 alligator clips hooked up to the battery. Okay, hook one on that terminal, one on this one. There's a magnetic. You hear that? Once you hear that clicking, that's good. That means that the magnetic coil is causing an electromagnetic pull and pulling a little lever in there and opening and closing it. As soon as you apply voltage, it closes it. It completes the circuit. It makes the fan come on. But you don't even have to go through all this. I just wanted to show you this just in case you wanted to know about it. So that's how you test the cooling fan relay. Okay, that test I just showed you on checking the fan motor and the relay, you don't even got to do all that. All you need is a jumper wire like this. Disconnect this from the fan switch, take that out, pop this in there like that, and watch the fan come on. See, take it off, put it on. You can hear the relay working at the same time. Listen. You hear that? Now, fan. Okay, we know our fan works. We know our relay works. We isolated the fan and the relay. Now we're down to this sensor, or the circuit could be a problem. Okay, before we start it, hook everything back up. The fan, relays back in. Let's hook this up. All right, put this back on. Now let's start the car up. Okay, we got the engine warming up now. All right, it's not fully warmed yet, but we're gonna let it get to operating temperature. That'll be around 210, somewhere around there. All right, so right now we're at 158 degrees Fahrenheit. So we're gonna wait a little bit, and this fan does not come on. Just to let you know ahead of time, this fan does not come on, and I'm showing you how to diagnose it. Okay? I'm gonna show you that this is gonna be at operating temperature, and at a certain temperature, that switch should kick on, and that sensor should tell the computer what to do, or tell it when to switch on. But something's going down with either one, or we got a problem in the wiring, in the circuit. So we're gonna figure out why the fan's not coming on. Okay, next test, we're gonna test the coolant temperature sensor. What I did is I warmed the car up, and we got it up to operating temperature. We got it at 205 right now. This car operates at a good 205, 200, between 200 and 210, around there. So what we're gonna do is we're gonna check the resistance on the coolant temperature sensor while the engine is hot, nice and hot. Okay, what I did is I turned the engine off. We got the car at 205. Temperature's around 205 right now, it's hot. And we're gonna check the resistance. I got this on the resistance scale. So let's pull this off. The engine's hot, so take that off. We're gonna put these on here. That one on that one there, and put this on and check the resistance. As soon as I put this on, we're gonna get some resistance, and we need to be between, what was it, 100 and 500 ohms of resistance. Right now we got 209 ohms of resistance. That's good. So we know we got a good temperature sensor. All right. Okay, we're at 225 degrees right now Fahrenheit. Nothing's coming on, no fan, nothing, no activity. So I'm gonna turn the car off so it doesn't overheat, and then we're gonna do the next test, all right? Okay, back here, remember we're at 225 degrees right now. I got the connector hooked up, got the leads, alligator clips, on that, checking the resistance on this sensor here. We got nothing. This should be closed, the circuit in here should be closed. All right, so we got nothing there, and something's up with this here. Okay, the resistance on the coolant temperature sensor is pretty decent, but this right here, fan switch, is kind of suspect to me. So what I'm going to do is I'm going to take it off and I'm going to test it. Pull that off like that, and it's bench tested right now. Okay, we got the fan switch out. I believe this is suspect, man. This might be the problem right here. Why do I believe that? Because what I have here jotted down is this switch I got right here. I know the writing's sloppy, but oh well. When it was cold, it was open. When it was hot at 225 degrees, plus or minus, it was still open. So that tells me right now that this may be the problem. Most likely it is. So what we're gonna do is we're gonna test it out. We're gonna bench test it with this. What this is a homemade boiler can slash coolant temperature sensor boiler tester, whatever. I just made it. It's from a can. I sanded the deal, then broke the top down and just put it like that. All right. So what we're gonna do is fill it up with water, and we're gonna boil it with a propane tank. But don't worry, if you don't have a propane tank, you can still use this over the stove. I'll show you right now, okay? So I got that filled up with water, right? I'm gonna connect the connector like that, so that we know we have contact inside. I'm gonna put this on resistance. Now, let's hook this up. Like that. Put that up there. Now, put all this to the side. Okay, we're gonna stick this in there. All right, that's fully submerged in the water right there. Okay. So now what we're gonna do, I'm gonna show you the temperature of the water. Ready? This is a temperature probe. It's hooked up to my meter. So that's inside there. Let's go to the temp. Show this. Okay, this water is at 81 degrees Fahrenheit. All right? So now we're gonna boil it. Okay, we know this water is at 80 degrees right now. All right? So let's take all this out. We're gonna start boiling this water right here. Okay? I'm gonna make sure that it's up. It's filled up. Add some more water like that. It's good to go right there. Okay, next. Let's heat it up. Okay. All this is a propane tank. All right. I'm heating this up. Okay, ready? Okay, we're gonna wait for this to boil. As soon as it boils, we're gonna put the sensor in there and check the resistance, or if we have continuity. It's gonna start boiling pretty soon. Okay. See the bubble? Water boils at what, 212, 208, 212? Right there. We're boiling right there. See, that's just from a can. That's just from a can right there. Okay, ready? Let's boil it again. Now, let's check the temperature. Show that meter right there. Okay, we're at 196, 198. 201. Okay, now what I'm gonna do is put the fan switch in there, like this. I'm just gonna set it in. The water's hot, all right? Show the temperature. Put this back in here like that. Okay, our temperature's at 180 something. Let's get it back up to 2 something, all right? This fan switch opens up around 199, 207, okay? Now, we're gonna put this on ohms, okay? Right now, the fan switch is in the open position. Okay, now we're going up to, we're boiling now. Okay? Now this switch, show this. Resistance, nothing. So we got an open circuit on this sensor right here. Okay? So at 207 and above, this switch, this one's done deal right here, no good. So this fan switch is no good. I picked up this one from the junkyard. This is a totally different one. I got this from the junkyard, all right? So I'm gonna slip it in like this. Put it in there. Refill this with water. I'm gonna fill it up. Remember, these fan switches open up around 197 to 2 something. Between 197 and just say 210, around there. This switch has to close the circuit inside and then provide current to the fan to open up, to turn the fan on. Okay, so let's heat this up. Okay, we're at 193, 195. It's getting hot. Water's starting to expand. We're at 204. Right there, we're boiling. Now switch it to resistance. Show that. Right there. This switch is, right now, this switch is closed. The circuit inside the switch is closed. Because remember, we have the terminals hooked up. We have these 2 terminals hooked up to the fan switch. Show this still. Now watch, as this cools down, this switch is gonna open. Leave it just like that. I'm gonna sit here and let it cool down, and you're gonna see the switch open. Okay? This water is very hot. You know what? Forget waiting. I'm gonna pull it out. I'll leave it there, leave it there, leave it there. Okay, now I'm gonna pull it out and cool it off, and watch how the circuit will open up. Watch this. See that? Now the fan switch, the circuit is open now. Now let's do it one more time. We're gonna close the circuit. This can is hot. Okay? A little bit more water. This time I'm not gonna show the temperature. I'm just gonna show when the circuit closes inside the fan switch. All right? No, we're not gonna show the temperature this time. Okay? Okay, now show this and this at the same time. Okay, you ready? Watch that, watch the multimeter. When this reaches a certain temperature, around 199, 200, the multimeter is going to show continuity on the fan switch. As soon as this water starts to boil, you're going to see it. It's starting to boil. Now watch the meter. Pay attention to the meter. Any second now. Right here, watch the meter. There you go, right there. 4.6, 4.7, 4.5. Thank you. Now, this switch, the switch is now closed, which means once it closes, It's going to provide current to the fan and turn the fan on. This is the one from the junkyard. And that's how you know that it's good. So anyways, that's how you test the sensor. All right? And right now, what we did is we just isolated every single thing that's related with the fan. Because remember, the fan wouldn't come on. So now we just isolated all that by doing these simple tests. And that's how simple it is. But remember, when you go to test these things, these sensors, whether it's this, that's hot, whether it's this fan switch or the coolant temperature switch, you got to make sure you know what your range is. So now let's put this one in the car, and then let's start it, and then watch to see if the fan comes on. Okay, for those of you who don't have a propane tank, you can put the can right on the stove. See how we got a circuit that's closed, that's open. The meter's saying the circuit's open. Watch when I put it inside in the water. That water should be around 208, 212 because it's boiling. Make sure you use your glasses. And watch the scale. See that? See that change? That means the sensor circuit just closed in there because it's a thermistor. One more time. Put it back in. Watch the meter. And right there. See? So you can do it right over the stove too. And I'm going to put it on now. Remember? Yeah, go ahead. Go ahead. Remember? Okay, that's good right there. Let's hook this up. Got that in. Let's start the car. Wait for the fan to come on. Okay, we got the new coolant fan switch in there. And we're waiting for the engine to reach operating temperature. We're at 154 degrees Fahrenheit right now. We're gonna wait till this hits around 199 or 2 something, all right? In order for that fan to come on, okay? This is the one from the junkyard. It was $6. All right, so let's wait for a little bit until this hits around 2 something, 199 or 2 something for the fan switch to kick on. So here we go, 205. There it is right there, 207. The fan should be coming on any second now. $207 right there, should be coming on. Give it a few seconds. We're at 207. Right there. There it goes right there. At 207 degrees Fahrenheit, that's when this coolant fan switch completes the circuit, sends voltage to the fan, and kicks it on. And that's how you diagnose a fan that's not working. This is a 97 Honda Civic 1.6, and right now I just showed you the process of elimination on how to diagnose the fan. So what we did is let's do a recap. What we did is we tested the fan through this switch here, the fan motor switch. There it goes again. Then we tested the relay individually. Then I showed you how to do it without having to take them apart and do them individually. You take this off, bypass that, short it out, turn the ignition on. It'll send power to the relay and to the fan and make the fan kick on. That way you know this whole circuit is good. Okay? Then we isolated it by checking the resistance on the coolant temperature sensor, and that came out pretty good. All right? So that was all good, and everything led to this bad boy right here because we had no continuity when the engine was cold and during when it was hot. Okay? So that's how you diagnose a fan that's not working. And that's how you diagnose a fan that's not coming on. That's called the process of elimination. You tackle each one individually, and then you narrow it down to the suspect. which in this case was the fan switch in the back here. That's it, man. Hope this helps you out. Don't forget, man, put Jesus Christ first in your life. Don't ever give up, man. Never, never. Never say the task is too great. And stay strong out there, man. Handle it. In Jesus' name, man. Go get it.